Okay, so for inductive and deductive reasoning, we'll talk about exactly what each one means. These are vocab words that you'll have to know. These are two different things. So make sure you're writing down the definition as I write it. Inductive reasoning is reasoning based on observations of facts. The important part here is that we know that it is based on patterns. It says often in mathematics we use inductive reasoning by observing a pattern. Write the next three numbers and the pattern. So go ahead and get a calculator out if you have it. Alright, so look at this letter A. We have number 1, 1/3, 1/9, 1/27. They ask for the next three numbers in the pattern. Okay? What do I notice that's in common here? Diana, what do you think? What's in common? We have 1, 1/3, 1/9, 1/27. What's happening? Multiply one by 3. The denominator, you mean? Yeah. The bottom number? Yes. Okay, so if they want the next three numbers, what's 27 times 3?
Boy.
81. I'm not just going to write 81 though. What's my pattern?
1 over 81.
Good. 1 over 81. Alright, what's next?
80. Do it again.
Yep. So 81 times 3? So 1 over 243. Alright, and last one, we need 3. So 243 times 3.
729.
Good, so 729. Okay, so those are my three numbers. For letter B, let me calibrate this for a second.
Because 1 is 6, we're
Good.
So doesn't it go like 1 instead of 3?
Good, so from 2 to 3 I added 1. And then from 3 to 5 I added 2. 5 to 8 I added 3. 8 to 12 I added 4. So my next number I'm going to add how many?
Not 5.
5.
So it's 12 plus 5.
15. I mean, oh my
17.
17. Alright, next I'm going to add by 6.
23.
Alright, my last number I'm going to add how many? 7. What do we get? Careful. 30, right? 23 plus 7, you get 30. So that's my pattern there. You guys have learned these patterns, so you at least learned inductive reasoning when you were in elementary. Sometimes you did shapes, sometimes you did numbers or patterns, it's the same concept. Alright, letter C, we went from 8 to -4 to 2 to -1. What are we doing? You guys see the pattern? Let's leave the fraction out of it right now. We're subtracting?
Yes.
Okay, so let's say, well,
Subtracting by
4.
oh,
between 4 and 2.
negative.
How do I get from 8 to 4?
Plus 12.
How do,
12. 8 minus 12.
okay, is that the same pattern though? -4 minus
No,
12?
because then you add
Think in terms of dividing.
Divide by 4.
Divide by 4? What's 8 divided by 4?
2.
Is that our next number?
Nah.
So we're dividing by what? You guys recognize that these numbers are in half. We're dividing by 2. From 8 to 4, divide by 2. From 4 to 2, divide by 2.
We're dividing negative 2.
Negative 2. Good. Okay, next point. We're also, there's a negative in between each one, so we're dividing by negative 2. All right, so in your calculators, let's do 1/2, which is positive, divided by negative 2. What do you get?
Negative 125.
Math, enter, enter.
Enter. Negative 1/2.
Wait.
Negative
Oh,
1.
no, 1/4. 1/4.
So we get negative 1/4.
Oh my god, we gotta do this like 3 minutes.
Well, all you have to do is just hit divided by 2. No, just hit divided
Oh
by.
yeah, and then it just keeps.
Because your answer pops up. Math, enter, enter. What do you get? Negative 1/4 divided by negative 2.
Oh, negative 1/8.
Negative or positive?
Negative.
You should get positive. Make sure your 1/4 was a negative. Was it?
Yeah, I don't know what it is.
You just messed up your sign. Alright, now we're going to do that divided by negative 2. You get negative 1/16. Okay, do we all recognize these patterns that we have right here? Alright, so there are also some real life inductive reasoning examples. It says, after picking marigolds for the first time, Connie began to sneeze. She also began to sneeze the next 4 times she was near marigolds. Based on these experiences, what can you conclude?
She's allergic.
Okay, that's what everyone's saying. She's allergic. Did they say anything about her allergies? No, we can infer that. Like that's kind of the next step. But based on what it says, all we know is that marigolds do what? Make her sneeze. Write that down. Based on what they gave us, that is all I can judge from this.
What type of name is that?
Connie?
Marigold.
Oh,
Marigolds isn't the name, that's the plant.
That's wild.
All right, number 2 says, every time pitch has thrown a high curveball to slugger, slugger has gotten a hit. Based on these experiences, what can you conclude?
Yes, it.
Slugger is going to hit. I'm just saying, based on the conclusion or the hypothesis, slugger will hit the curveball. We have real life inductive reasoning all the time. If you want to go somewhere at 5 p.m. on 495, what can you conclude about that? Is there going to be traffic or no? Really? During rush hour?
Oh, you didn't say.
Like if you take that road every day and you know there's traffic, you're going to kind of find a different way.
Take the back roads.
Mm-hmm. All right, and counterexample. This is another vocab word you guys need to know. A counterexample is an example that shows a conjecture. We talked about this on day 1, it's just a guess. So an example that shows a conjecture is false. So deductive reasoning is reasoning based off data or facts. So what I like to think about is inductive reasoning is about patterns, deductive reasoning is about data. I'm reminded by deductive by the word data. So you will use inductive reasoning to make conjectures, and deductive reasoning to show that a conjecture is true or false. Okay, so we have some vocab words again. We have law of detachment and also law of syllogism. Okay, these two things are also on the back of your cheat sheet. So we're going to fill this in. Your law says if the hypothesis of a true statement is true, then the conclusion is true. The hypothesis of a statement is true, then the conclusion is true. That is all of detachment. You also have symbols for this. If P to Q is true, and P is true, then Q is true. At this point, you should recognize P as hypothesis, Q is conclusion. So an example, if a student gets an A on the final exam, then the student will pass the course. Which one is my hypothesis and what's my conclusion? What's the hypothesis? If the student gets an A on the final exam, right? That's my hypothesis. My conclusion is that she will pass the final exam. Sorry, that she will pass the course. Then it said Felicia got an A on her final exam. So if she got an A on her final exam, then what happens for the conclusion? Then what? Then she passes the course. What we're looking for here is that if my hypothesis is true, my conclusion is true. So my hypothesis was that if she gets an A on the final, or that A student gets an A on the final exam, they pass, and they said it was true. But she got an A on the final exam, so my conclusion was true. Your non-example here says if the student gets an A on the final exam, then the student will pass the course. Once again, this is P, and that's Q. And then it says Felicia passed the course. Do you see how this one just went right to the conclusion? It didn't go back to the hypothesis like over here. So therefore, I cannot make a conclusion out of that. Let's put an X. No conclusion. Okay, does everyone have these words written down?
Yes.
Okay. For law of syllogism, and we'll write this on your blue sheet in a little bit. For law of syllogism, I just have symbols for you because the law was way too long. But let's write if P to Q is true, and Q to R is true, then P to R is true. What I want you guys to write is, I think of this as the middleman, or there's three parts to the law of syllogism, and we're looking to see if we can cut out the middleman. So if P to Q is true, Q to R is true, then P to R is true. All right, let's take a look. If it is July, would that be P or Q?
Oh.
That's P, that's my hypothesis. Then you are on summer vacation. What's that? Q. Okay, that's what we've learned so far. Then it keeps going. If it is summer vacation, what letter should I get that? Because that, right, it still gets Q. You guys see that? Okay, it still gets Q because we're still talking about summer vacation. Then you can work in the smoothie shop. I'm going to call that R. That's what my R comes look like. Do you guys see how my Q's are in the middle? Okay, that's what I want. When my Q's are in the middle, I can cancel out the middleman. Okay, so my conclusion is going to be, if it is July, then what? Good, then you can work in a smoothie shop. If it is July, then work in a smoothie shop. So when you do these laws, you have three parts to it. We had P, we had Q, and we had R. You're looking for your Q's to be in the middle. If they are, you can cancel them out. Last one before lunch. If it is July, well, that's going to be P. Then you're on summer vacation. That's Q. If you are at the beach, what letter does that get? Is that the same as Q? No, this is a whole different one, right? We call that R. Then you're on summer vacation. That's back to Q. Do I have my Q's in the middle to get rid of my middleman? No. So therefore, there's no conclusion. That was a non-example. All right, go to lunch. So we have example one. Example one says, describe how to sketch or sketch the fourth figure in the pattern. All right, look at your first figure to your second to your third. What's happening?
It's getting smaller and smaller.
Okay, so the blocks are getting smaller. What else?
They're adding more black.
Good. So in my first figure, I have how many black and white? We have one each. What about in the second figure? There's how many of each, right? That'd be consistent. So we have two each. All right, what about three?
Four.
So what do we think our figure is going to look like for the fourth figure? There's going to be how many black and white slots? Huh?
6, 8.
Why do you say 8?
Or it's 4 on both.
So the real reason is because you guys see that my pattern is doubling from each figure. Okay, we're not adding it, we're not subtracting it, we're actually just multiplying by 2. So here I multiplied by 2, I got figure 2. I multiplied by 2 here. So my next one, what's 4 times 2? We'll have 8 blocks of red and black. So Sydney, you were right, but if you kept going, if you were doing it at 4, your next one will be wrong. So our next one should be what? 16, right? So we're doubling it. So that's my pattern, is to double.
That's hard also. What's the... I want to fall asleep this time.
All right, example 2. Find a counterexample to disprove the conjecture. A conjecture means this is guess. If the name of the month starts with J, then it is a summer month. Is that true or false?
What?
If the name of a month starts with J, then it is a summer month. Is that true or is it false?
False.
Why?
Oh my god.
What else could it be?
A, B,
Guys, do you understand what just happened? If the name of a month starts with J, then it must be a summer month. Is that true or is it false? It is false. Jackie, why is it false? Which it is? Thank you. It could be January. So that would be false. A counterexample proves the conjecture is false. Letter B says if an animal is green, it is a frog.
false. True.
What could it be?
Snake.
What else could it be?
Yo, I'm just gonna be from.
Hey, you're not understanding this, so pay attention.
Gecko. I don't know.
What else could it be? A lizard. We could go on and on, okay? Letter C, supplementary angles are always adjacent. Why is that false? If I have a supplementary angle, it's two angles that add up to give me what? 180. So let's say I have this angle is 120, and this angle is 60. Are they two angles that add up to 180? Why not?
Yes.
Yeah, what's 120 plus 60? Supplementary just means two angles that add up to give us 180 degrees. These angles are not adjacent, because adjacent means next to, but it's still supplementary. This is from our vocab last week, or last unit, that you guys didn't study for, so that's probably why you're a little confused. Example 3, use the law of detachment to make a valid conclusion in the true situation. Law of detachment means that if my conclusion is true, then my hypothesis is true. So if two angles are right angles, this is our conclusion. If two angles are right angles, then they are congruent. Then it says, bless you, angle C and angle D are right angles. So what can we conclude? We're saying if two angles are right angles, then they will be congruent. Therefore, if C and D are right angles, what can I conclude from that?
They had two angles.
Nope, not, well, I see what you're thinking, but not 90, but they will be what? What's my conclusion?
They're right angles.
What's my conclusion?
Yeah,
They are congruent. So we can conclude that angle C is congruent to angle D. What we're doing is we're looking at our hypothesis and our conclusion, and then we're making our own conclusion based on what they give us. All right. If Nathan is enrolled at Metro High School, then Nathan has an ID number. Nathan is enrolled at Metro High School. What can we conclude?
He's going to school. He's enrolled in.
What is my conclusion? Whoever's from that is, please turn it off. Example 4, if possible, use the law of syllogism to write a new conditional statement that follows the pair of true statements. So, if Joe takes geometry this year, is that going to be my hypothesis or my conclusion? We have to be sure on this, guys.
Yes.
right? Because whatever is after it is my hypothesis. Then he will take algebra 2 next year. Is that my conclusion? So we have Q. If Joe takes algebra 2 next year, would that be P or would that be Q?
Q.
Why do you say Q?
You already talked about it.
Yeah, because it already mentioned it. Then he will graduate. We're going to call that R. Do I have a middleman here?
Yes.
Yes. You guys see that my conclusions are in the middle. I cross out the middleman. What am I left with? What's my sentence? That he will graduate. Good. You guys have one more example.
Yes.
All right, last one. If angle 1 is obtuse, then angle 2 is acute. If angle 2 is acute, then angle 3 is obtuse. Do we have enough information here? Do we have 3 parts? Let's see. If angle 1 is obtuse, that's my hypothesis. Then angle 2 is acute. That's my conclusion. If angle 2 is acute, that gets acute. Then angle 3 is obtuse. Do I have a middleman there? There's some middleman? No. Both of your conclusions are in the middle, right? You guys don't see Q and Q side by side?
Dude, no.
Yes. It's gotta be the middle. I'm tripping.
It's in the middle of R and R.
Oh, okay. I'm tripping.
Okay. Yeah,
No.
no. In the other schools. No. All right. I'm going to cut out my conclusion. So what is my my sentence here? If what? If angle 1 is obtuse, then what?
Angle 3 is obtuse.
I think in minutes, yeah.
Could
At least she's answering.
I know. Yeah.